Hi, everybody. Let's talk a little bit about similarity. In your notebook, you have some definitions of similarity. You know that if two figures have the same number of sides, then that is one of the criteria, same number of sides, right? If they have equal angles, that's the symbol for angles, then we know that that's another criteria for something to be similar, for two figures to be similar. And the last one is that side lengths need to be proportionate. So I'm going to use the symbol for proportionate. And so those are the three things you want to be looking out for if you're being asked a question about similar figures. So let's take a look at this one. I will make a copy here, and I'm just going to move it over. And right now you can see these are exact copies of each other. So they are clearly similar. If I make it a little smaller, I should see that it should be proportionate, right? Because I shrunk the height and the width at the same rate. Okay? So let's take a quick look at that. If I say that this height, you might see a problem where there's a height of 4 and this has a width of well, let's call it 4. It looks like they're equal. So I'll call it 4. And this might be something like 2 and 2. The height and the width were reduced at roughly the same rate, right? So there's our scale factor, and so we got one that was proportionate, right? So we can tell by the side lengths, right? We also know that the angles did not change. We can tell that the angles did not change, right? Just when the size changes, the shape didn't change, okay? The problem we run into is when a figure looks like so. The same triangle, if it is turned this way, trying to finish turning it, it may look like it is in fact a different triangle when it's not. Right? This angle did not change. It's still, well, it looks like it's probably a 90. And just like this one, it didn't change. It didn't get squashed or stretched out. It's just that the sides no longer do this thing we call correspond, right? So we can look at these two and think that they're not similar, when really they are. This side was still 2, and this side is still 2. This angle is still 90, and this angle just corresponds over here. So sometimes when you see a shape, you just need to make sure that you know the corresponding angles and the corresponding sides. Right? So sometimes we'll label them. Let's talk about how you might be able to do this. Triangles are often labeled like so. Call this corner B, or vertices A. Sorry, that's not a B. A, and we'll call this one B, and call this one C. And then our task over here is to see what corresponds. Well, look for what you know, right? We see the 90-degree angle. Here, that angle or vertex is A. So over here, we call it A. And then we can imagine, it looks like this was rotated clockwise, right? And so if A is here, what happened to B? Well, B used to be here. It should have moved down here. So now this is B, and C would be over here. So now when we think about what sides correspond, it should be easier for us to match them up, right? And we can also name things. Like, for example, we could say side A, B. We could write it just like that, was 4, right? And we could say side AC was 4. And that would identify this side and this side. And if we want to make a proportion, we just need to look for those same things. Over here we could say, where is side AB? Oh, it's right here. Side AB is 2. And here we can say side AC, this side right here, is 2. And then we can check and see if they're proportional in a number of different ways. We could say, okay, does it have the same scale factor? Sure, they both are divided by 2. Or you can cross multiply, right? We could say, okay, 4 times 2 would be 8, and here 2 times 4 would be 8. Yes, they are proportionate because these cross products are equal. Okay, so don't let things fool you. If they don't look similar because of rotation, don't worry about it. Well, do worry about it, but try and figure out which angles correspond. Look for clues to tell you what angles go together, okay? You don't want to make the mistake of thinking that this down here, AC, would somehow correspond to this, CB, because they're both on the bottom, right? That's not what corresponding means. We don't want to just call it the bottom of the triangle. Okay? These are similar triangles. One of them has just been rotated. So we need to be aware of where corresponding angles are. Okay, I hope that helps. Thanks.